It is visible?
Yes, sir. Yes, sir.
Yes. Okay. Just keep keep with you on pen and paper. Okay. And try when I'm discussing. Just if you are not getting, then please stop me and ask me. Okay. So the last class we are discussing about the ones complement or different type of conversion. So whatever we are discussing. So that particular part also we are continue, and some part we are not discussing till now. Suppose in this particular slide we are discussing about the two's complementary representation, and this is popularly generally we are widely use this particular presentation. Okay, this is called a two's complementary representation, and we are discussing different type of methods of two's complement. Okay. So after that, we will discuss some other topic. So just we are starting from here also. Here. So two's complementary representation means what? So what is the basic idea? Basic idea is that if when we are going to use the two's complementary representation, always remember positive numbers are represented. When the positive numbers are occurred, that time what happen? We are represented exactly as in sign magnitude form. So also no, we are already discussed what is a sign magnitude form. So no need to do anything about the positive numbers when we are applying the two's complement. That means what? It is similar to the sign magnitude form. Okay. But main role is coming of two's complement is that when the negative numbers are occurred, the negative numbers are represented in two's complement form. That is our main task actually. We are dealing with the negative numbers. Okay. So next point is C, computation the two's complement of a number. So how we are using the representation of the two's complement. So what happen? You know the complement means what? Just opposite one. Particular one object. What is the opposite of that particular object? That is the general definition of the complement. Okay. So when we are applying the complement in the binary digit, that means you have already know what is the ones complement form. Okay. So two's complement means what? Complement every bit of the numbers. That means what? We are complementing every bit. That is called obviously by default it is called a ones complement. And then add 1 to the resulting number. And at first what we are doing? We are complementing the numbers. It is behaved like as a ones complement. And after that what we are adding 1 to the LSB, not a MSB. Okay. So that particular part is called a two's complement representation. So next point, see here, MSB will indicate the sign of the number. Okay, so MSB bit, that means MSB means what? Most significant bit. It is indicate that 0 is positive and the 1 is negative. Okay, so what is the, if whatever we are discussing, if you are writing in the expression format, that means what? Two's complement equal to one's complement plus 1. Okay, next. See here, just I am giving one particular example. This particular table is important to use, just to clear the concept. So see here, the left hand side we are using decimal. The first column we are using decimal, and third column also we are using the decimal value. Okay. So see here, all the +0, +1 up to +7, the MSB all are 0. When we are applying the, because this is the, we are not doing the two's complement, because what happen, all the numbers are positive. So it is similar as a sign magnitude form. But when we are using the third column, see here, we are starting from -8 and we are going to -1. So always remember, so when we are representing the 4-bit numbers, then what is the range? Range is -8 to +7. That means when we are applying the 4 bits number, that means n equal to 4, that time what happen? The range is -8 to +7. We cannot go beyond that one. And if you are increasing that bit, then obviously we can do that one. Okay, this is the basic concept. So see here, so -8, suppose I'm here, I'm using how we can apply the, suppose -4. So -4 is, see here, at first what happen? We can find out the complement of 4, +4. Okay, +4 is what? What is the magnitude, sign magnitude from 0, 1, 0, 0. Now what happen? We are applying the two's complement from. So two's complement from, what is the first step? First step means that we are doing the ones complement from. So 1, 0, 1, 0, 0 of 0, 1, 0, 0, the ones complement is that 1, 0, 1, 1. And after that, what is the second step? We adding plus 1 to the MSB. When we are adding, that time what happen? We are using 100. The laser pointer is coming.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Coming, sir.
So,
Yes,
so
sir.
this one see here 0100, and after that what happen? We are using 100, 1011 plus 1. So what is the our main task when we are representing the two's complement? So what happen? 010, 0100, we are using the ones complement, and the generated number is 1011. After that second task is we are getting plus 1. So here we are getting 11100. See here -41100. Are you getting my point? So similarly, we are using -8 also, -1 also. So what we can see here, the MSB bit, the first one, the first MSB bit, that means MSB bit all are 1. So what happened? This one is the indicates that this one means what? It is the minus sign. Okay. So we are this particular table only for n equal to 4. And you always remember when we are applying n equal to 4, what is the range? Range is -8. If we are talking about the sign, sign symbol, that means the range is -1 to -8. And when we are talking about the +7, that means what? 0 to 7. Okay. See here, when we are talking about the range of the two's complement form, then minimum range is what? -2 and -1. The earlier what happened? Earlier, when we are talking about the ones complement, the range is -2 to the power n minus 1 -1. But what happened? We can increase one length. Minimum. See here how we can increase. We are going to -1 to -8. One bit is increasing. Are you getting my point? The same thing when we are applying the ones complement from that time what happened? What is the range? Range is -1 to -7. But in this particular case, what happened? We are using -1 to -8. Can you tell me why this one is increased by 1? So what happened? Our minimum range is, it is starting from -2 to the power n -1. But maximum is same. Same in the sense that it is the same two's complement also and the ones complement also. Because what happened? Here we are using 0 plus 0 to +7. So anyone can tell me why the range is -2 to the power n -1? Anyone?
So I think because in two's complement we are adding another 1 to the one's complement.
No. That one is the only the method. That means when we are doing the two's complement form, that is the one particular method. Okay. So it is not any relation. That means why this minimum number is range is -2 to the power n -1. So when we are adding +1, that is the representation of two's complement. It is not related with this particular place. And here, okay, you are trying. Anyone can tell me why this one minimum is -2 to the power n -1? Why we are not using -1? That means why we are not writing -2 to the power n -1 -1? Okay, I am telling you just so be careful. So whatever your concept must be cleared. So every class is very important to you.
Sir,
So
positive numbers are in sign magnitude. That's the reason.
Yes. Pardon. Please repeat.
Positive numbers are in sign magnitude and negative numbers are in two's complement.
So how it is affect in the effect on minimum number? So my question is that why minimum is -2 to the power n -1? I don't know. Maybe your answer is correct, but I'm not getting your answer actually. My question is that when we are talking about the ones complement form, the minimum value is -2 and -1 -1. Okay, but
Sir, 0 will never come in the negative part.
Yeah. Yes, it is correct, but yes, correct, but partially it is partially correct, but you are not getting the, because people can understand easily. That means your answer is something like that in between the yes or no. That means maybe it is correct, maybe some I am getting your answer, but it is not a expression power is not okay. See, it is very simple. See here. So if you are carefully check this particular table, the table is the answer. See here, in ones complement form, the when we are representing 0, it is maybe a plus 0, it is maybe a minus 0. Okay, so what happened? We are getting some particular two different, that means same number, we are getting the two different values. Yes or no? Are you remember, na? For ones complement form.
Yes, sir. Yes, sir.
Okay, plus 0, we are using some different combination of bit sequence, and minus 0 also we are assigning some different sequence of bit sequence. Okay, so what happened? Same value, because if you are going conceptually, plus 0 equal to minus 0, because it is 0. But what happened? The binary sequence are different. For plus 0 also different and minus 0 also different. But remember one thing, in this particular, when we are applying the two's complement, that time what happened? I am very much sorry. Who is someone is trying to join. Okay, plus 0 is plus 0 we are representing 0, 0, 0. And minus 1 we are representing, sorry, when we are applying the minus 0 also, that time one also we are getting 0, 0, 0. That means what? Here only for representing 0, maybe it is minus 1 or it is plus minus 0 or plus 0, it is does not bother for us, but we are using only one particular bit sequence, that is 0, 0, 0. For that particular reason, what happen? We can increase one particular length. We are going to minus 7 to minus 7. Are you getting my point? Are you getting my point?
Sir, can you repeat it again?
Okay. So the same table we are using in ones complement form for n equal to 4. You can check that particular table. Okay. So what happen if we are just again I am going just a minute. Again I am going this one. See here. This particular PPT is visible to you, all of you.
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
See here, this one is the ones complement table. We are discussing about two's complement table, but for your understanding purpose, I am using this one again. See here, plus 0 is what? 0, 0, 0. Yes or no?
Yes, sir. Yes, sir.
Plus 0. What is the first complement of plus 0? 0, 0, 0. Because we are using n equal to 4. Only we are using 4 bits. Okay. But same thing when we are applying minus 0, that time what happened? Represent this 1, 1, 1, 1. Yes or no?
Yes, sir.
So that means what happened? We are using two different bit sequence to represent the same number. So what happened? We are going for, because what happened? Otherwise what happened? If plus 0 and minus 0, the sequence is same, binary sequence is same, that time what happened? We are not using this particular minus 0 or plus 0. We can use only one. Or generally what happened? It is starting from plus 0, so we are not using minus 0. So obviously what happened? Instead of minus 0, we are writing here minus 1. And it is going up to what happened? Because we are using 4 bit, it is going to minus 8. But this is not the case in the first complement form. Because what happened? Minus 0 also represent, if instead of 1, 1, 1, when we are representing minus 0, if you are using a binary sequence 0, 0, 0, that time what happened? Your answer is wrong. So minus 0 means what? Minus 0 is 1, 1, 1 and plus 0 is 0, 0, 0. So our limitation is only what? Our maximum limitation when we are using the ones complement, maximum is to the power minus 1, and minimum is to the power n minus 1, minus 1. Okay, but when we are using the two's complement form, see, this is the two's complement form, plus 0 also it is representing 0, 0, and minus 0 also it is representing 0, 0. Or generally what happen? When two's complement we are using minus 0 means meaning is same. That means same values are repeating. Okay. For that particular purpose, we are not using here minus 0. And when we are not using minus 0, that time what happen? One space is vacant, and that particular space it is representing minus 8. Because you know, when we are representing 8, decimal number 8, only 4 bit is required. So that is the satisfaction. We are doing the, this is the advantage. This is the advantage of 2's complement over than the 1's complement. Now you are getting?
Yes, sir. Yes, sir.
Yes, sir.
Okay. So next one. So this is, so maximum is okay. Maximum, that means we are going from +0 to +7. Okay. Minimum is, so when we are using the -7. So based on this one, so different type of advantage of 2's complementary representation. That means, see here, whatever we are discussing till right now, that is the first advantage, unique representation of zeros. That means what? We are using the zero. Whatever we are discussing, that means zero, the only one particular representation is occurred in 2's complement form. So whatever range is -2 power and -1. And see here, subtraction. Then earlier also it is when we are talking about the 1's complement, this is also advantage for 1's complement also and 2's complement also. So whatever using the complement, maybe it is 1's complement, maybe it's 2's complement, we are generally whatever we can easily use the, using the 2's complement form, we are easily using the subtraction. Okay, so no need to require for extra circuit for subtraction. We are adding, based on the adding and using the 2's complement, we can complete the subtraction. So this is the complementary representation is very, very essential in digital circuit. Okay, so for point number 2, the point number 2 is satisfied. So obviously what happens leads to the substantial saving in the circuit. So what happens, suppose suppose this is the particular circuit, suppose this is the black box, suppose what happens, we are interested to join A plus and B. Okay, and suppose some particular output is coming, it is called as C. But what happened, remember one thing, so what happened, this is the circuit for A plus B. Okay, and whatever the output is coming, it is coming in the form of C. So same circuit concept we are using for subtraction also. No separate circuit is required. So what happened, suppose instead of plus, suppose we are using here minus here. So we are not using this one. Suppose we are not, just it is a, suppose we are using the same circuit we are using based on this particular 2's complement and 1's complement. Okay, are you getting my point? Are you getting my point?
Yes, sir.
Yes, sir.
So what happened, we are using same circuit for plus also minus also. That time what happened, we can say we can substantially saving the circuit. Okay, now what happened, what is the special, one particular special case in the 2's complement representation? What is the special case? And this particular point is very important. Okay, so whenever a sign number has 1, sign number must be, that means what? Sign number 1 means what? MSB always 1. MSB always what? Equal to 1. Okay. When sign, because MSB always represented the sign numbers. Okay, MSB number has 1 in the sign bit and all zeros for the magnitude bit. Okay, the decimal equivalent is -2 to the power n. This one is very important. Okay, it is -2 to the power n. So what happen, always remember, when MSB is 1 and all other remaining bits are zeros, that time what happen, we can directly use this particular, when we are representing the 2's complement, don't need to +1 and all those things, just you can apply -2 to the power n. Okay, this is the special case. It is not why we are using this one is the special case, because this particular concept is not for all others binary sequence, and this is only for those binary sequence whose MSB is 1 and all other remaining bits are 0. Okay, now see here we are taking one example. n is the number of bits. What minus 2 to the power n means what? N, the 2 to the power n means what? Here n is representing number of bits in the magnitude. Okay, and magnitude, you know, that means what when we are using the sign equal to plus magnitude. That means one particular all the sign plus magnitude is called a magnitude. Okay, that means all are the magnitude. For example, suppose what happen here 100, 100. So that means what? See here MSB is 1 and all other remaining bits are what? 2 to the power 3. How many magnitude bits are there? 3 bits. So n means what? It is magnitude. 2 to the power 3 means what? Minus 8. Just you can represent it in the form of minus 2 to the power n. So n here is representing the magnitude. Okay, magnitude means what? Magnitude, suppose what happen? Some particular part is there, this one, this one, this one, this one. So what happen up to this is called a magnitude. Okay, this one is called a magnitude and this one is called a sign. Okay, sign bit. So what happen if we are using for see here 5 bits 1000, that means what? We can write in the form of minus 2 to the power n. So what happen here? It is minus, and how many bits we are using in the magnitude from n equal to 4. 2 to the power 4 means what? It is 16. So it is minus 16. Okay, this is the special case in 2's complement representation. And remember one thing, why 2's complements are, because almost all the computers today representing the 2's complement for storing the negative numbers, because it is very efficient to storing the negative numbers. So these days what happen? All the for 2's complement we are using for storing the negative numbers. Okay. And just a minute. Actually, my internet connectivity is going down, so just I'm giving the search. Just wait for. Okay, so next see here, when we are using the 2's complement form, there are different methods we are using. So if anyone have a doubt, please ask me, don't hesitate. Otherwise, your concept is not clear. Okay, please you stop me and ask me. Are you getting my point?
Yes, sir.
So what is that? There are different type of complement methods we are using when we are using the 2's complement method. So what happened? The first method is called by obtaining the ones complement of the given number by changing all zeros and ones to zeros and then adding. We are discussing this one. It is very simple. As generally people are using this one. So other two methods are also okay. For understanding purpose, you can use this particular 2 and 3 also. The second method and third method. What is the second method? By subtracting the given n bit number n, capital letter N. I will discuss what is n, capital letter N, from 2 to the power n. Okay, so some particular n bit number is there. We are denoting as a capital letter N, and from we can subtract from 2 to the power n. So this is the second method. Well, I will explain with the help of example. And the third method is called starting the LSB, that means least significant bit, and copying down each bit up. Okay, and include the first one bit encountered. When one bit is encountered, we are starting from LSB, and after that we are copying one by one. And what happened? Include the first one bit encountered. So when it is copying down, when it is one bit is encountered, that time what happened? We are doing the complement of the remaining bits. So that means what? When one bit is encountered, then obviously what happened? The remaining bits we are complementing. That is called a third method. Okay. Suppose we are using this particular example and we are applying this particular first method. So here I am writing first method means what? Number 1. Okay. So method 1 means what? The example says that minus 45. Because plus 45 it is a not meaning, because it is similar to the sign magnitude from. So minus 45, here minus 45, we are using the 8 bit. We are using the 8 bit 2's complement form. Okay. So how we are using the first method? number 1. Okay. So what happened? So we know we are, whatever we are writing the binary sequence, always we are writing in the 8-bit because question is demanding like that. Because it is the 8-bit. So how many bits are there? 1, 2, 2, 3, 4, 5, 6, 7, and 8. Okay. 8 bits are there. Okay. So this particular 8-bit is representing 45. See here 0, 1, 2, 3, 4, 5. 2 to the power 5 is 32. 0, 1, 2, 3, 32 plus 8 plus 0, 0, 1, 2, 4, 4 plus 1. So it is 45. Now what happened? According to the ones complement, this one is the conversion. We are converting to the ones complement form. That means what? 0 goes to 1, 0 goes to 1, 1 goes to 0. So it is, we are doing the ones complement form. This one we are doing the ones complement form. Okay. After that, what happened? What is the next method of twos complement? We are adding 1. So when we are adding 1, that time what happened? We are getting 1, 1, 0, 1, 0, 0, 1, 1. Because 0 plus 1, 1. This one is 1. This one is 0. This one is 0. This one is 0. This one is 1. This one is 0. This one is 1. This one is 0. Okay. So this one is the method 1 is very simple. Okay. All the methods are very simple, but you have to know. Okay. You have the concept. So any doubt this one, method 1, any doubt?
No, sir.
No,
Okay.
sir.
No,
So
sir.
second method, see here.
No, sir.
Second, so yes, very good. Second method is that by subtracting the given n-bit number, n, capital letter N, from 2 to the power n. Now, the same example we are applying the method 2. Okay. So here, see here, subtracting the given n from 2 to the power n. Okay. So what happened? 0, how many bits we are using? 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, am I not mistaken? 1, 2, 3, 4, 5. No. 0, 1, no, sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, this one is 9. And the next one is, this one is 8. See here, subtract the given number n from 2 to the power n. So here n means what? Number of bits. So small letter n means what? Number of bits. How many number of bits we are using? 8. Yes or no? We are using 8. So what happened? And what is the n? Capital letter n. N means what? 2 to the power 8. Just a minute. 2 to the power 8 means what? 2 to the power 8 means what? 2 to the power 8 means what?
1.
256. 256.
256. Okay. And what happened? This one, this particular 2 to the power 8 means what? This one is called n equal to, we are using n equal to 8. Okay. Now what happened? When we are converting 256 actually converting in this particular form. This one. 1. How many zeros are required? 1, 2, 3, 4, 5, 6, 7, 8 and extra. So total bit is 9. But remember one thing, the question is only says that 8-bit. But remember, this particular n, we are talking about only n. So n is representing in this particular form, 2 to the power n. That means n is representing what? 256. This particular 256 means what? It is called a capital letter N. Okay, if we are not using this particular one here, I am writing 1. That time what happened is this representing is what? 128. See here, we are starting from, this is the weight is 0. This one is weight is 1. This one is weight is 2. So this one is 0. This one is 0. 0, 1, 2, 3, 4, 5, 6, 7, 8. So 2 to the power 8 means 256. Are you getting my point? After that, what
Yes,
happened?
sir.
We can subtract n from 45. So here 45 means what? 45 we are representing because subtract. So we are using minus because method 2 is already directly defined that you can subtract this particular n. Okay. So n means what? N is representing here 45. Are you getting my point? Sorry, here it is not a 256. Sorry, here it is not a 256. And sorry, because it is representing to the n to the power n equal to 256. Yes, it is correct. But here n equal to 45. Sorry for mistake. So this one is 45. So 45, you know how many bits are required. That means this is the 8-bit. So what happened to construct the 8-bit? We are using unnecessarily. We are using 00 because question is specifically demanded. We are using 8-bit. So what happened? How many bits are there? 1, 2, 3, 4, 5, 6, 7, 8. And this one is the 10001. Okay. So this one is the representation of. We are not using till now any 2's complement and all those things. Okay. Just we are writing in the 45, positive 45, and before that we are using the subtract. So here we are using minus. So just we are, though I am not discussing till now plus 0, what is the arithmetic operation. That means we are not discussing subtraction and addition. But though you just remember 0, 1 means what? It is 0, 1 means what? It is 1 actually, and the 1 is carrying. Okay, 1 bit is carried to here. So this one I will discuss later. This one very clearly. So this one is 1, 0, 1, 0 means 1. Again, this one is 1. So this one is because carry bit is generated. So instead of 0, here it is 1. So 1, 1 is 0. And after that, what happened? This one is also 1, 1, 1 is 0. And this one is also 1, 1 because carry is generated till now. So 1 minus 0 is 1. And this one is 1, 1 is 0, 1, 0, 1. And what happened? This one is coming here. 1 minus 0 is 1. So this is the answer. See here, we are getting 1, 1, 0, 1, 0, 0, 1, 1. And when we are applying the method 1 also, that is we are getting the same result. That means 1, 1, 0, 1, 0, 0, 1, 1. Because it is does not it is whatever method you are using, 1, 2 or 3, the answer is remaining same. Okay. So this is the second method. Any doubt this one? Second method, any doubt?
Yes, sir.
Second method, any doubt?
Yes, sir.
Please ask me. If you have any doubt, then please ask me.
Sir, I didn't get subtract and 45. How is that?
Sorry, I am not getting your voice clearly. Please tell me clearly. You can ask me.
Sir, second point to subtract N45.
So what happened? N45. So this is the example. Okay, this is the express minus 45 in 8-bit 2's complement form. So what happened? This one is the second method. But second method is says that by subtracting the given n-bit number, n, I'll discuss now. I'm discussing already what is n from minus 2 to the power n. So that means what? We are using 2 to the power n minus n. So here we are not using any 2's complement and all those things. Just this is the method of 2's complement. But remember, this is the method of 2's complement. Just we are using this particular concept. Here n means what? Small letter n means how many bits actually we are using. Okay. Suppose what happened? That means for the time being, you just remember n means what? How many bits we are using. Okay. And n means what? Capital letter n means what? What is the given number? Actually, we are going to complement. Just two things. It is two things are required. Okay. So small letter n means what? How many bits we are using, and capital letter n means which particular number we are going to use complement. Okay. So see here when we are using the 2 to the power n, what is the value of n small letter n? I am talking about the small letter n. Can you tell me? What is the value of small letter n?
8.
8. So 2 to the power 8 means what? 256.
256.
Now just you can represent the 256 in the binary sequence. That's all. Are you getting my point? When we are representing the 256 in binary sequence, then how many bits are representing 9 bits? But your answer is still now, your method is correct. Okay. It is not like that. It is you can maintain the 8-bit because our method is saying like that. If it is small letter n equal to 8, just you convert to the 2 to the power n. So 2 to the power n means what? 2 to the power 8 equal to 256, and when we are representing 256 equal to 256, 2 to the power 8 equal to 256, and 256 we are representing in this particular binary sequence. Now what is the n? capital letter N, this particular N. Capital letter N means what? 45. Now what happened? We are using subtract. For subtract here we are using minus symbol. This one is the minus symbol. And this N equal to what? 45. So 45, though 45 we are representing 6 bit is required to represent the 45. But if you are writing 101101, that time what happened? Our answer is wrong. Why? Because question is demanding the 8 bit. So what happened? In the MSB side, we are to make the 8 bit, we are using 2 zeros.
Okay, sir.
And after that, what happened? Generally, we are doing the subtraction. So what happened? Generally, what happened? When it is 0 minus 1, that time what happened? Equal to what happened? This one is 1, and what happened? 1 is coming. Okay. The MSB 1 is called a carry, and this particular carry is propagate here. Okay, this particular carry is coming from here. So what happened? 1 means what? Instead of 0 here, we are writing 1. So 0 minus 1, 0 minus in 1 is what? 1, because this one is 1. So this one is 1. Again, this one is what happened? Carry bit is generated, so borrow bit is generated. So 1 minus 0 is 1. Again, what happened? 1 is 0, because this one is carry bit. Instead of 0 here, I'm getting 1. So 1 minus 1 equal to 0. Again, this one is 1. 1 minus. So this way we are using. But remember what in arithmetic operation, subtraction is too much difficult. Now subtraction is a little bit complex than the addition. Okay. For that particular purpose, we are generally using the complement, 2's complement or 1's complement, because what happened? The same circuit for addition we can also apply in the subtraction. But though this particular part of how we are doing the addition and subtraction, we will discuss clearly after a few minutes. Okay. So this one is the method 2. And what method 3 says that starting at the LSB, copying down each bit up and indicate the first 1 bit encountered. And when 1 bit is encountered, then remaining bits just you can complement. That's all. See how we can, the same particular example we are using the third method. See here, the original number is what? Original number is 45. We are not using. We are not, just a minute here. Yes. The original number is what? Original number means don't consider here minus 45. You don't consider here minus 45. Okay. Just you consider only 45. Don't use minus. The original number is what? 45. So 45 we are representing as a 0, 1, 0, 1, 0, 1, 1, 0, 1. Now what? Copy up to the first 1 bit. See here, first 1 bit just we are copying, because first bit is we are starting from LSB, not a MSB, according to the method. So LSB is what? Just 1. And method 3 says that first 1 bit encountered, when 1 bit is encountered, that time what happened? Complementing the remaining bits. So 1 bit is already encountered, we are copying here. Okay. So that time what happened? Just what happened? This particular 1 is copying here and 1 is remaining same. And other sequence from left to right, 0, 1, 1, 0, 1, 0, 0, we just complement. So 0 goes to 1, 1 goes to 0, 1 goes to 0, 0 goes to 1, 1 goes to 0, 0 goes to 1, and 0 goes to 1. And same thing is the result. So result is what? This one. So 1, 1, 0, 1, 0, 0, 1, 1. So this one is also, if when we are applying the method 2, then also result is same. When we are applying the method 3, then also result is same. And when we are applying the method 1, then also result is same. So that is the 3 methods. Generally, people are using the first method. Sometimes it is because it is, but this method also very good. When your binary sequence is very large, you can use this one also. This one is third method also very easy. And second method, if you are comfortable with the subtraction, then also you can use the method. Okay. So any doubt about the method 1, method 2, method 3?
No, sir.
एक आदमी क्यों बोल रहा है? बाकी क्या हुआ? बाकी सब बोलिए.
No, sir. No,
No,
sir.
sir.
No, sir.
No doubt, sir.
Okay. So प्लीज ट्राई टू रेस्पॉन्स ऑल पैरेलली. ओके, एक ही बोलता रहेगा ऐसा कोई नहीं है. आप किसी का मतलब ये मतलब रेस्पॉन्सिबिलिटी लेकर नहीं रखे हैं. ये आपको भी पास करना पड़ेगा, बाकी लोगों को भी पास करना पड़ेगा. सो and if you are responding is not well, then my interest also goes down. So on time, regularly you can respond. Okay. Okay, try you write down this particular example. Write down this particular example fast. Express minus 73.75 in 12-bit 2's complement form. And whatever I'm using the marker, it is visible to you, na?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. Now you can apply method 1, method 2. You can do yourself method 1 and method 3. Now, though the answer is already given and the competition is already given, but when you are doing yourself, that time what happened? Some doubts or some concept is not clear, then you can ask me. I am giving only 5 minutes to you. Just complete this one. And you can check the method 1, method 2, and method 3. And if you are just writing something from the slide, then I'm going to the next slide, then please stop me. Okay, sir, I'm writing, please stop this particular slide. Then I'm waiting for you. Are you getting my point?
Yes, sir.
Yes, sir.
Yes,
Now,
sir.
when we are applying the minus 73.75, and this one is not a 8-bit, remember, this one is the 12-bit 2's complement form. So 12-bit means what? It is the total cardinality or total degree of the sequence is 12-bit. It is not right that before decimal point it is 12-bit and after decimal point it is 12-bit. So all total, before decimal and after decimal, that means fraction, all are together, total number of bits is 12. The first method is very simple. Check this one. So at first what happened? You can find out the value of positive 73.75. Okay, not a minus, 73. What is the binary sequence of 73 and what is the fraction part? How we can convert fraction part to the binary sequence? Okay, so from this one we are getting this particular number. After that, this particular number we are converting to this one with the help of complement. That is called a ones complement. 0 to 1 or 1 to 0. Now what happened? We are doing 2's complement. So here we are adding plus 1. So this is the first method, is very simple. Now method 2 and method 3. You can just check, and if you any doubt, then please ask. क्या हुआ? You are keeping very silence. You are doing or not?
Sir.
Yes, sir.
Doing, sir.
You are taking so much time. Really, method 2 is getting or not?
Yes, sir.
Done, sir.
Done, sir.
Okay.
Yes, sir.
So बोलना पड़ेगा ना, because you are silent, so I am also. So method 2, it is okay. Everything is clear. Any doubt? Someone is any doubt? Please ask me. Don't.
No, sir. No, sir.
No, sir.
Clear, sir. Clear, sir.
So remember what happened here. 2 to the power n means what? We are not using, because small n, we are not using 12. Small n is not a 12. Remember. Small n is 8. After fraction part, how many binary bits we are using? 4. 4 plus 8 means what? 12. So we are getting 12 bits. Are you getting my point? So before fraction
Yes, sir.
part, it is 256, because if we are using 12 bits, 12 plus 4, it is 16 bit. But question is demanding only 12 bit. So what when before fraction part we are using 8 bit. Okay, not here. Here means n value is small letter n is 8. 2 to the power 8 means what? 256, and 256 we are representing in this particular sequence, in this particular up to this. After that, what happened? 8 we are declaring as a 8, and how many bits here? 4. 1, 2, 3, 8, 9, 10, 11, 12. And other parts are remaining same. 73.75 you can use minus, and after it is 75 we are denoting as a what? 1100. So just you can minus this one. So again 0, 0, 0, 0, 0 minus 1, 1, 1, 1, 1 is carry. So 1 minus 1 is 0. So here 0 minus 1. So that means what? This one is 1 is already carry earlier. So 1, 1 is 0. This one is 1 minus 0 is 1, 1 minus 0 is 1, 1, 1 equal to 0. 1 minus 0 equal to 1, 1 minus 0 equal to 1. And 1, 1 equal to 0. This one is coming here. 1 minus 0 is 1. So this is the answer. Now you can say same thing. If you are representing 73.75, that time what happened? This is we can represent this one, this particular form. And why somebody asks then why we are using here 0, 0 and why we are using 0, 0? Because what happened? The question is 12 bit. See here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 bit we are constructing. Okay. After that, see here 0, 0. The first bit is not a 1. So it is 0, 0, 0, 0, and 1 is encountered. When 1 is encountered, that time all other remaining bits are complement. So 1 goes to 0, 1 goes to 0, 0 goes to 1, so something like that. So we are getting, see,
Sir,
all the yes.
Sir, I have a doubt. You told her that we just need to copy the first one bit. Then why did we copy the second, the two zeros after one?
Okay, what is your name?
Sir, Anku, sir.
Very good, Ankur. See here, you have some confused, you have some doubt. See here, the method says that you can read very carefully. Number 3, starting at the LSB. This one is the LSB, this one is the LSB. Yes or no?
Yes, sir.
This one we are starting from LSB. Now see here, starting at the LSB, just a minute. Starting at the LSB, copying down each bit up. Up means what? We are copying down from the up bit, whatever upper position is there, and include the first one bit encountered. So what happens when one bit is encountered, then remaining bits are complementing. That particular part very important for method 3. Now see here, in this particular example, see here. So 0, 0. Now first bit is what? We are starting from LSB, but first bit is 0, not a 1. So what happens as it is, we are copying down.
Yes, sir.
But we are not using any complement, because method, according to the method 3, when one bit is when one bit is encountered, so next is 0, but till now it is not a 1, so we are not complementing, so it is as it is 0, 0. Now when we are going from LSB to the MSB, the third bit is C here 1, so 1 is encountered. So first bit, what happens when 1 is encountered, this particular one we are copying down this one as it is. It is not like we are not complementing this one. Remember, when one bit is encountered, just we are copying down as it is. But remaining bit we are complementing. So what we can see here, 1 0 is complement, 1 it is 0 is complement, 0 1 is complement, 0 1 is complement, 1 0 is complement, 0 1 is complement, 0 1 is complement, 1 0 is complement, and 0 also it is complement. And same thing we are repeating here also when this is the final answer. And all other, this one is also same, this one is also same, and this one is also same.
Yes, sir. Understood. Thank you.
Okay.
Yes, sir.
So next, so now the slide is complete. So now we are moving to the other slide. Just wait for a few minutes. Oh. Now next we are discussing how we are arithmetics, that means binary addition and subtraction, how we are performing the binary addition and subtraction. Okay. So what when you know binary number system is widely used in digital system because digital system in nature in the binary form. That means what? The voltage range is either 0 or either 1. Okay. But when we are talking about the analog system, that means what? It is the continuously events is occurred during the it is based on the current and voltage. So any numbers can occur 0.195 some particular. So there are different type of range are there. But when we are talking about digital system, voltage range is in between 0 and not in between either 0 or 1. Okay. But when we are talking about the analog system, some particular range are there. There are different type of values are occurred that within that particular range. So generally what happens when we are talking designing some particular system and when we are talking about a digital system, we are binary number system are mostly widely used. So see here, this if your this particular is this particular table is concept is clear to you, that time what happens you can easily perform the subtraction, addition, and multiplication. So suppose we are discussing for 2 bits, it is maybe 3 bits, 4 bits, something like that. So when suppose here I am using in A 2 bits A and B, and this one is the sum operation, this one is the sum, this one is the subtraction, and this one is the multiplication. Okay. So here 2 bits means what? We are denoting as a and B, and this one is the value. This is the binary sequence form. We are writing 0 1 0 1, and after that whatever 0 0. That means what? We are going up to 0 to 3. Decimal number 0 to 3. Okay, total is 4. So 0 0 0 1 1 0 1 1. This one is 0. This one is 0 1 is 1 in decimal form. 1 0 is 2 and 1 1 is 3. So when we are applying the sum addition, that time what when you know in addition there are 2 outputs are generated. One is sum and one is carry. So when we are using 0 0, the sum value is also 0 and carry value also 0. When we are using 0 plus 1, that time what happens? Sum value is 1, this one is 1, and this one is 0. Okay. And when 1 0, that time also sum value is 1 and 0, carry is 0. But when we are using 1 plus 1, that means A equal to 1 and B equal to 1, that time what happens? Sum value is 0. But carry is generated, so carry is generated, so here I am writing 1. That means carry is active from. And same thing we are defines 0 minus 0, that means borrow also defines also 0. 0 minus 1 means what? Defines is 1 and borrow also 1. 1 0 means what? This one is the 1 minus 0. The time what happens? We are getting here 1. So defines is 1, but no carry is generated. So no borrow is generated. So it is 0. Okay, this one is 0. And after that, what happens? 1 minus 1 means what? Defines also 0 and borrow also 0. And same thing but here what happens when we are using the product, there is no concept of borrow and carry. So only particular one output is generated. So what happens? 0 into 0 is 0, 0 1 to 1 0. When only one bit is 0, that time whatever the output 1 and 0, whatever the other inputs 1 and 0, it does not border, always outputs are 0. When both the inputs are 1 1, that time only the output is 1. That is the concept. Okay. So based on this particular concept, just how we are representing how we are performing the binary addition. So see this one, corresponding bits are added, and if a carry 1 is produced, it is added to the binary digit at the left. Okay, and always remember, when this type of binary addition we are performing, we are going from LSB to NSB, LSB to MSB. We are not moving from MSB to LSB. Okay, suppose in this particular example, see here, this is we are interested to adding 0101. We are interested to adding 1011. Okay, so 01 means what? This one is 1, and no, initially what happened? Why initially there is no carry. Okay, it is null. So 01 means what? 1 is generated, but there is no carry. So here I am writing 0. 0 plus 1, 1 plus 1 means what? 1 plus 1 means what? 1, 0. So 0 is adding term, and 1 is the carry bit. Okay. Sum, sorry, this one is 0 is sum, 0 is sum, and 1 is carry. So 1 plus 0, 1, 1 plus 1 means what? 0. So sum bit is 0 and carry bit is 1. Again, we are adding here 1 plus 1 is 0. Sum is 0 and carry is 1. So 1 plus 0 plus 1 means what? It is 1 plus 1 means what? 1, 0. So this one is 0 and this one is carry. So this is the same thing. See here in this particular example also. 1 plus 1 is 0. So 1 is generated, 1 plus 1 is 0, 1 is generated, 1 plus 1 is 0, 1 is generated, 1 plus 1 is 0. Now then this one is also. See this one, 1 plus, so you are, this way we are performing the binary addition. Any doubt this one?
No, sir.
No, sir.
No, sir.
So how we are using the subtraction? Subtraction little bit complex compared to the addition. But if you know the concept, then it is no problem. See here, 0 minus 0 means what? 0. Initially what happened? Here it is empty means what? It is nothing, null. So 0 minus 0 means 0. So what happened? Difference is 0 and borrow is 0 also, because no borrow is generated. So here I am using 0. This one is 0. Okay. 0 minus 1 means what? Sorry, 0. Sorry, 0 is 0. So 1 minus 0 means what? 1. Difference is 1 and borrow is also 0. That means no borrow is generated. So it is 0. But when 0 minus 1, that means what? It is 1. 1 and 1. See here 0 minus 1 according to the table. 0 minus 1 means what? 1. This one is also 1 and this one is also 1. Okay. So for that particular purpose, what happened? 0 minus 1. See here 0 minus 1. This one is 1 and difference is, borrow is also 1. So 1 minus 1 is 0. 1 minus 1 is what? 0. And there is no borrow is generated. So it is 0. I am writing here 0. So 1 minus 0. So 0 minus 1 means what? Sorry, 1 minus 1 is 0. Are you getting my point? So see here 0, 0. Finally, what happened? We are getting 0, 0, 1, 1, 0. Same things here. If we are talking about this particular example, see here 1 minus 1 is 0. So no borrow is generated. So 1 minus 0 is 1. No borrow is generated. 1 minus 0 is 1. No borrow is generated. 0 minus 1 means what? 1. And 1 is generated. Borrow is now generated. So 1 minus 1 equal to 0. In this particular example, see here in this particular example. So 1 minus 0 is 1. 1 minus 0 is 1. 0 minus 1. That means difference is 1 and borrow also 1. So 1 minus 0 is 1. Okay. And 1 minus 0 is 1. Then this one is what? No borrow is generated. 0 minus 1 is 1, 1. Am I correct? 1, 0, 1, 1, 0, 1, 0, 1, 1, 1. 1 minus 0 is 1. 1 and 1 minus 1 minus 0, 1 minus 0, 1, 0, 1, 1, 1 minus 0 minus 1, 1. Okay, so this particular one is okay. Any doubt, please ask me.
First example, leftmost term
0, 1 minus 0, it should be 1.
Which one? You are talking about the first example. This one.
Yes,
This
sir.
one.
Yes, sir.
Yes, sir.
Okay. See here. See here. 0 is 0. Yes. Okay. So 1 minus 0 is what? 1.
1.
Because 0 minus 0 means there is no borrow. So here I am writing 0.
Yes.
Are you getting my point?
Yes, sir.
Yes, sir.
So what happened? So 0 means nothing. So 1 minus 0 means what? Again it is 1. So when we are performing the 1 minus 0, that time what when borrow also, we are not generating any borrow. So it is, this one is 0. This one is 0. Okay. Now what happened? 0 minus 1. 0 minus 1 means what? It is borrow also 1 and difference also 1. So this one is borrow is 1 and this one is 1. Are you getting my point?
Yes.
So what happened? 1 minus 1. 1 minus 0 means what? 1. Again 1 minus 1 is 0. So here we are getting 0.
Yes.
Now what happened? There is no borrow is generated. So what happened? 0, no borrow is generated. What happened? So what happened? This particular one, 1 minus 0. Oh yes, this one is,
Yes, sir.
1.
this one is maybe 1. Okay. Okay, this one is maybe 1. So this is the correct. Any doubt this one? Other two examples? Instead of 0, just you can write 1. This one.
Yes, sir.
Any doubt this one and this one?
No.
So
No.
what happened? Somehow it is you can just maintain the borrow and with the other bits, because borrow is propagated to the LSB to the MSB. If no borrow is generated, then always borrow is 0. Otherwise it is 1. Okay. So little bit, if you are practicing that time, however, it is also easy. But compared to the addition, this one is little bit complex. Okay. But it is okay. It is tolerable. Okay. Then we are going to the next slide. Any doubt this one?
No, sir.
No, sir.
Now what when we are talking based on that particular concept, now how we are binary addition and subtraction actually we are using.
Sir. Sir,
Yes, tell me.
sir, the last example, you can you get back to, sir, the first example, if we convert into decimal, the first number will be, I think, 18. In the decimal, if we convert it to decimal and then subtract, and what was written there, that should be right. 0, 0, 1, 1, 0.
0, 0, 1, 0.
First, 16 minus 12.
You are just a minute. You are talking about the first example, or you are talking about the last example?
First example.
First example. Just a minute. Again, I am checking because I am not checking it clearly. So this one is 0. Okay. 1, 0, 1 minus 0 is 1. 0 minus 1 is 0. 1 minus 0 is 1. So it is borrow is 1. Okay, 0. It is okay. 0 minus 1. So 0 minus 0. So just a minute. 0 minus 1. 0 minus 1. This 1 and 1. Okay, good. So what happened? 1 minus 0, 1. 1, 1 equal to 0. And after that, what happened? 0. So see here some particular cases are there. Actually, it is not. I think this one is not a 1 actually.
Yes, it will be 0.
This one is that it will be 0. How we are zeroing? See, you remember when we are suppose 3 2. Okay, 3 2 minus 5 7. Suppose I am giving one example. This particular 32 is not representing this one, but I am giving one particular decimal example. That time what happened? This to first one 2 minus 7. That time what happened? That means we are borrow from 3. That time what happened? This one is 12. Yes or no? This one
Yes,
is
sir.
12 minus 7. 12 minus 7. And after that, what happened? This remaining 3 is what? Now it is no more 3. Now it is converted to 2. This is the normal how we can performing the minus. So same thing here. This particular one, that means what happened when it is this particular one is no more occurred here. Okay, only 0 and 0 is only remaining, because what happened, this one is propagated to the LSB side. Somehow some particular bits it is using. Okay, for that particular purpose, what happened, there is no one is concept is there, so it is only 0 minus 0, so this particular 0 is coming. So I am confusing it is 1 or what, but this one is, I think this one is correct. The correct form is there, 0 0 1 1 and 0. This is the
Yes,
correct.
Yes, I tried converting it into decimal and solving, and I'm getting 0011. 0.
So just you can go, so maybe you can, I'm also forgetting because I'm not practicing too much, but it is very easy. When you are going to practice, then you can automatically understand. You can just check this one and the second one and third one also. Are you getting my point?
Yes,
So
sir.
it is not a too much hard. It is not a, don't confuse this one. It is very easy. So addition and subtraction, when we are trying to 1 and 2, do an example of, for example, then you can automatically understand. Now we are going to the next particular slide. How that now we are discussing about the how we are performing the addition, how we are performing the subtraction. Okay, so based on this particular concept, how we are using the arithmetic operation based on the addition and subtraction. Okay, and you know, when we are applying the ones and twos complement, that means separately we are not using any subtraction. That means these particular things are not required actually. These particular things are not required. Okay, because we are using here subtraction we are using. That means minus a minus b. So naturally what happened? This is the natural process. We are subtracting this particular one to this one. So this is the natural one. So what happened? This particular part we are not using when we are using the ones and twos complement form, because I have already discussed when we are using the complement form, no need to do the separately in subtraction. Addition we can perform, subtraction as well. Okay, so based on how that means how this particular command is correct. Okay, for that particular purpose, see here we are using subtraction. We are computing the we are actually our main objective is subtraction, but we are not using any subtraction. We are applying the addition. Based on the addition, we are performing the subtraction. And it is only possible when we are using the complement form. You can use one complement also, and you can use the twos complement also. It is no problem. But twos complement form is very much simple than ones complement form. Now, suppose how to compute a minus b. So this is the process. Okay, you can carefully go one by one, then you can automatically understand. So how you can compute a minus b? A value is anything and b value is anything. Okay. So if we are applying the ones complement, then this is the process. The first step is that compute the ones complement of b. Now remember, why I am not using the complement of a? Because this is the positive. So positive is similar to the sign magnitude form. So no need to do the complement. But we are because minus is in front of the b. So we are interested to do the first complement of b. So what happened? We are using the first complement of b, and we are saying that we are assuming that this one is the whatever the complement form is coming, that particular complement value we can store in b1. Now what happened? R, we are taking one for just I'm considering this particular variable. You can consider any particular variable x, y, z, and whatever. R equal to a plus b1. So when we are computing r equal to a plus b1, that time what happened? When you are computing when the result is coming, okay, a plus b1, then there are two parts. One is if carry is generated after addition 1, that means what? After addition 1, that means we are using the addition 1. After addition 1, if carry is generated, that time what happened? We are follow this particular step. And else what happened? The result is negative and is in one's complement form in R. So if carry is generated, that time what happened? Add the carry back to R. Okay, carry back to R, and this one is called a and around carry. This particular carry bit, whatever the carry bit generated, that particular carry bit is called a and around carry. Now what happen? After that, what happen? We can add R with plus 1. Okay, and the result is positive number. The result is positive. Okay, and otherwise what happen? This particular part is not coming, carry is not generated. You can use the simply negative symbol in front of the number, and this one is the ones complement of the original number is R. Okay, so just we are taking one example. So 6 minus 2. So this one is what? This one is the B. 2 is B. So what is the first complement of 2? First complement of 2 is what? What is the decimal value of 2? 0, 0, 0, 0, 1, 0. What we are getting? We are using the ones complement form. That time what we are getting 1, 1, 0, 1. Okay. Now what is the complement of? No, what is the binary sequence of 6? 6 is 0, 1, 1, 0. Okay. And remember one thing here, we are using, suppose we are considering the 4-bit number. This particular one we are using 4-bit, but if it is 8-bit also, 3-bit also, so 4-bit, so extra this particular 0 is offered to maintain the 4-bit. Now what happened? What is the ones complement of 2? Ones complement 2 is 1, 1, 0, 1. So this one, whatever the value is generated, that particular value is called as R. Now if it's generated after addition 1, so what happened? This one is the complement form. Just a minute. Here I am getting. So 0, 0, 1, 0. Yes or no? This is the first complement of 2. Yes or no? 0, 0, 1, 0. And after that, what happened? We are complementing this one 1, 1, 0, 1. Okay, good. But this one is not the 2's complement form. So for doing the 2's complement form, we are adding here 1. So what we are getting? We are getting 0, 1, 1, 1, 0, 1, and 1, 1, equal 1, 0. Something I am missing here.
Sir, adding 6, 0, 1, 0, 0, 0, 1, 1, 0, 0, 1, 1, 0, 2, 1, 1, 0, 1.
Just a minute. 1, 1, 0, 1. Okay. So what happened here? It is not, we are not using. So minus 2 means what? Complete. It is the ones complement of B. So ones complement of B means what? This one is the 1, 1, 0, 1. According to this particular method, this particular step. Okay. So what happened? Here we are using. Okay. So I am confusing. So don't use this one because we are here. It is especially mentioned we are using only ones complement. Sorry, we are not using any 2's complement right now. Okay, so this is only for ones complement. Yes, it is correct. So now what happened? Here I am using. Now what happened? That we are not using the subtraction. Just we are using the addition. Okay. See here 0, 1. 0 plus 1 means 1. 1 plus 0 is 1. 1, 1 is 1, 0. That means 1 is generated as a carry, and 1 plus 1 is 1, 0. Okay. Now what happened? This one is 4-bit. And this one is the 5-bit. So this particular one is generated. Extra carry bit is generated. And this particular carry bit is called an around carry. And when, if carry is generated, then carry back to R. Again, what happened? We can add with the carry. And this particular carry bit we are using in the LSB side. Okay, we are adding with the LSB. So what happened? Right now, what happened? 1, 1, 0. What is the here? So this one is what? 0, 1, 1, 0. Okay. 1, 1, 0. This one is 1. This one is 1. So what happened? This one is representing as a plus 4 because 0 is the symbol of this 0. If we are considering 0 is the sign magnitude and this one is the positive. So this one is the plus 4. And same thing, see here, if I am applying 3 minus 5, that time what happened? The ones complement of 5 is what? The 0, 1, 0, 1. Here the ones complement is what? 1, 0, 1 and 0. So this one we are getting ones complement 1, 0, 1, 0. And 3 is what? 3 is 0, 0, 1, 1. So we can add this one 1, 1, 1, 1 plus 1 is 0, and this is the carry bit. So 1 plus 0 is 1, and this one is 0 plus 1 is 1. So we are getting 1, 0, 1. If the result is negative, excuse me, the result is negative, and it is one's complement of R. So this is the, we are, no carry is generated, so it is negative, we are using the negative, and this is the one's complement from. How it is one complement from? What is the 2? We are using 2. What is the 2's complement from? 2's complement
0,
from
0,
is
1, 0.
no, sorry, 2 is 0, 0,
0, 0, 1, 0.
0, 0, 1, 0. Now, if we are using the ones complement from, that time what happened? Ones, 1, 0, and 1. See here, this is the result is same of this. This is also we are getting 1, 1, 0, 1. This is also we are getting 1, 1, 0, 1. So here I am writing was complement from in R. Any doubt this one?
So I have a question.
Yes, good. Please ask.
So in case we just do the decimal, like we do the subtraction, sorry. In case we do the subtraction in decimal, and then the answer we get, if we just convert that into binary, wouldn't that be the same?
Yes, yes,
Like,
it is same. So what happened for that particular purpose, what happened when we are applying the, remember, that is the only, but one case is there. One constraint is there.
yes, sir.
Subtraction and addition perform same. Okay?
Yes, sir.
But if you are not using complement, that time what happened? It is something different. If you are using the complement, that time what happened? Maybe you are using the ones complement, maybe you are using the twos complement. Okay. But what happened?
Yes, sir.
The subtraction behave like as a addition. That means, sorry, when we are performing the subtraction, we are using the addition mode. See here, we are not using any subtraction operation. In this particular 2 example, though it is 6 minus 2, or though it is 3 minus 5, but never, anywhere we are not using any subtraction operation.
Yes, sir.
All the operations we are using only addition.
Yes,
So
sir.
that is the beauty of complement.
So actually, I mean something like if we are doing 6 minus 2, we can directly do it in decimal. We get 4, and then we convert 4 into binary, and we get the same answer. Why can't we do that?
Okay. So just a minute. It is very good question. It is not a good question, but it is something. Okay. What is your name?
So Rashtriwala, sir.
Okay. So previously you are asking. You are the same student who are asking previous question.
No, sir. That was Anku.
Okay. Good. Now you tell me 6 minus 2. It is okay. 6 minus 2, directly we are converting 4, and directly we are writing in this one. But remember one thing. So now 6 minus 2, you know, because you are the human, now you know 6 minus 2 value is 4. Now, but how digital circuit performs 6 and 2?
Logic gates.
Because yes, 6 minus 2 you know because equal to 4. Because you are not using any binary sequence or binary, you are not using any binary operation. Directly you can convert it decimal. 6 minus 2 equal to 4, and after that for 4 you are converting. Lastly for finally you are converting 4 to binary sequence. But how digital circuit is performed 6 minus 2, then up to 4, how digital circuit it is in the performance.
Yes, understand.
Okay, 6 minus 2 is because computer understand only binary sequence 0 and 1. So without converting the binary mode, it is never possible. So what happens? This type of operation is required. Are you getting?
Yes, I understand, sir. Thank you, sir.
So any doubt this one?
No, sir.
Any other student? Any doubt? मैं बार-बार पूछ रहा हूँ लेकिन any doubt? But if you are not replying, if you are not replying, and after few days, sir, मुझे ये समझ में नहीं है, मुझे ये part, then I'm very much stuck that time. Remember, and मैं आप लोगों को पहले ही बोला हूँ, when I am starting my class, please keep pen and paper with you. Okay.
Sir,
Yes. Yes. Yes.
Sir, in the second example, after adding the ones complement of 5, do we have to again the complement add negative to it?
No. It is not required because see here already I am giving the process actually. You see within the rectangular box. See here, if the carry is generated, see third point, if carry is generated, but in this here no carry is generated. So what happened? Directly we are going for else part. Okay. So what happens when no carry is generated? That time what happened? We are using the negative. That means we automatically know this one is the negative. Okay. Whatever the value is generated in decimal form, we are writing in the negative form because this particular first MSB bit is 1. So 1 means what? 1 means negative and 0 means positive. And after that, what happened? This particular one is representing in the 2 because here I am writing this one is the whatever the result is coming, it is the ones complement form in R. So see here 1101 is the ones complement form of what? 0010. And 0010 is representing as a 2 in decimal number.
Okay, sir.
Are you getting or not?
Yes, sir.
See here minus 5. Minus 5 means what? What is the actually A? Ones complement because this one is the minus 5. So minus 5 we are, though it is minus 5, so we are converting in the ones complement form. So ones complement form, what is the without form of 5, then what is the how we can representing in the 5? 0101. Okay. So but here what happened? We can use the ones complement form. So instead of 0101, this particular 0 goes to 1. This particular 1 is goes to 0. This 0 is goes to 1. This one is goes to 1. Now what happened? This is the ones complement form. And after that, what happened? We can add A plus B1. Suppose this one is the this one is the B1. This one is the B1. So A means what? A means 3. So A plus B1. So we are getting this one. Now we can say, add the carry. Carry is generated after addition is 1. So after addition, how we are writing after addition? So this particular part only. It's just you can check. This one is not required. It's confusing. If carry is generated, that time what happened? We can add carry back to the R. This particular, if carry is generated, that time what happened? We can add with LSB. If carry is, but here, see here, we are adding and 1101 is coming, so no extra carry bit is generated. So we are not computing this particular part. We can directly computing only this particular part. The result is negative. The result is negative, and it is the twos complement. So it is 110. Okay. Okay.
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Now this is the subtraction using addition with the help of ones complement. And second one, subtraction using addition with the help of twos complement. So this one is yes.
Sir,
Yes.
ये जो second example है,
Yes.
पिछले वाला कोई example था ना? हाँ वही. उसमें second example में जो आंसर आया है वो 1101 है.
Yes.
कंप्यूटर ये देख के कैसे सिर्फ ये बाइनरी नंबर देख के ये कैसे समझता है कि ये -2 लिखा है और 13 नहीं लिखा है?
Because this one is the bijective. Bijective means what? It is 1 to 1 mapping. When we are using the ones complement, automatically we can understand that -2 it is representing as a 1101. Now आपको कैसे पता चलेगा? आपको तभी पता चलेगा जब आप मेरा जो स्लाइड है वो स्लाइड क्लियरली देखेंगे. आज ये डाउट जो हुआ आपको इसलिए हुआ जो वंस कॉम्प्लीमेंट का जो टेबल है देखिएगा, मैं उस टेबल में 2 का वैल्यू क्या दिया हूँ 0010 और उस टेबल में -2 का रेंज क्या है, -2 का कन्वर्जन कैसे है 001101. ओके. सो इसीलिए क्या होता है 0010 when we are applying the ones complement only one unique value is produced, that is called a 1101 और कोई unique value उसका नहीं होगा. And computer, when we are writing some particular programming and when we are designing the machine language, that time what happen? That particular unique sequence convert to that particular binary sequence, not using twos complement, not using normal binary operation or any addition and subtraction. But when we are using the ones complement, then 0010, that means 0010 always getting the 1101. Now what happen, ये 1 to 1 मैपिंग है, वो कैसे पता चलेगा? क्योंकि 3 minus 5 का वैल्यू हमेशा -2 होता है, और -2 कैसे आया वो, this is with the help of this particular method. Okay. Okay, your doubt is again, if you have any doubt, then again you can ask me, no problem. If you can check the ones complement, the range of the, that means main दिखाया था ना आप लोगों को +0, +1, +2, and define side I am writing also -0. Then that time I am giving only 2 tables based on ones complement, one table with ones complement and one table with twos complement. Then so what happened? So this is the universally correct. This one is the universally correct. So here we are writing very clearly that whatever the results are generating, it is the always ones complement formed in R. So what happened? The result क्या होगा? इसका 3 minus 5 का result क्या होगा? -2. And जो -2 का जो result आएगा, -2 का जो result आएगा, always ये क्या होगा? ये 2 का ये complement form होगा. So for that way we are writing here is in ones complement form in R. Okay?
Yes.
So क्या होगा? आप लोग अगर सोच रहे हैं कि सर ने जो समझाया वो मेरे को एक ही टाइम में मुझे सीखना है और मैं उसके बाद बुक वगैरह खोल के नहीं देखूंगा, सर ने जो पढ़ाया था पिछले वाला सब्जेक्ट और पिछले वाला क्लास भी मैं नहीं देखूंगा, डायरेक्टली मुझे जब सर ने पढ़ाया है उसी चीज को मुझे समझना पड़ेगा. And I am already telling you, in this particular subject, if you are missing one particular class, it is very difficult to follow the other class. Okay, तो आप लोग तो अभी बड़ा इंजीनियर बड़ा साइंटिस्ट होने के लिए जा रहा है. Now right now you are not scientist. Okay, so आप लोग को समझ में आ रहा है, जो डाउट आ रहा है वो 2 ही चीज से आपको क्लियर होगा. Regularly you can go for the textbook and whatever till now I am discussing, and every class I am giving some particular task to you. Just you can go through that particular book and unsolve and just complete the solve and unsolve problem. Then what happen? Your concept is coming. Then your automatically concept will be clear. Okay, कोई concept आप लोग खुद समझेंगे और कोई concept मेरे साथ discuss करके आपको समझेंगे. लेकिन आप लोग blindly आप लोगों ने कुछ पढ़ा नहीं है. डायरेक्ट मैं क्लास करके जा रहा हूँ. आप लोग सडनली आप लोग का बहुत सारा कंफ्यूज इसलिए क्रिएट हो रहा है क्योंकि पहले वाला जो कॉन्सेप्ट आप लोगों का क्लियर नहीं. Whatever you are asking me 1101 ये कैसे -2 होगा? It is very simple because already I am giving the table of ones complement. You can check what is the +2 and what is the -2. And ये कैसे हुआ? Because what happened in this particular process, whatever we are applying this particular process, else part it is automatically mentioned that the is in ones complement form in R. Are you getting my point? So if you are asking me the question, it is very good. I am always supporting you. But as well as also you are thinking that sir ने जो आंसर को रिप्लाई दिया वो रिप्लाई में आप एनालिसिस करके देखिएगा. ठीक है, सर ने ये चीज क्यों बोला, ठीक है, तभी आपका क्या होगा, ये कॉन्सेप्ट क्लियर होगा. ओके, सो वी आर गोइंग टू द नेक्स्ट स्लाइड. सो गए क्या सब लोग?
Yes, sir.
Yes, sir. No,
बाकी लोग सो गए? मैं घर
Yes,
में
sir.
काम कर रहा हूँ टेबल में.
No,
Nice,
sir.
sir. Next, go to the next line.
Now what happened? The earlier we are discussing the ones complement of subtraction using addition. Now what happened? We are using the twos complement. So generally same example we are considering how to compute a minus b. Now what happened? Compute the twos complement of b, and here we are considering as a b2. Because earlier we are considering b1, so don't collision. So I am here using b2. Compute r a plus b2. If k, now yes, now this particular part is coming. If carry is generated after addition is 1. If carry is generated after addition 1, ignore the carry. The result is positive now. Else what happen? If carry is not generated, it is a negative and 2's complement of r. So this one is the very simple manner as compared to the 1's complement. See here, 6 minus 2. So what happened? The 2 is we are representing 0 0. What happened? 1 0. Now we are converting to this one as a ones complement from, and we are adding +1. Why we are writing this particular +1? Because this one is the what? This one is the 2's complement from. Okay. So when we are adding 1, we are getting 1110. So -2 we are writing in the 2's complement from. This one is a 1110, and 6 we are writing as usual because in front of the 6 it is positive. So 0110. Just we are adding, but though we are performing minus operation, but we are not using adding a subtraction operation. We are just adding the addition operation. 0 plus 0 1. 1 plus 1 is what? 1 plus 1 is 1 0. So this one is 1. Carry is generated. So 111 1 plus 1 is 0, and again 1. What that means? 1 1 is coming, and 1 plus 1 is 1 0. Okay. So according this particular procedure, what happens if carry is generated? So this one is the carry. This particular one, this one is the 1 is carry. 1 is a sorry. Here I am writing. So this one is the result is 1 0 1. So extra 1 bit is generated. Ignore this particular bit, and when we are right, ignore this particular bit, and result is positive, and this one is 0 1 0 0. So this one is the plus. Okay, and the next example, 3 minus 5. So here I am writing -5. We are this particular -5. We are converting as a 2's complement from. So we are getting 1 0 1 1. And 3 means what? We are using only 4 bits. So 3 we are converting 0 1 1 and 1 0 0. The result is negative because no carry is generated. Okay. So what happened? And 2's complement form of R. Now 2's complement form of R means what? 3 minus 5 is what? 3 minus 5 is -2. So how we can convert this one to 2 means what? 0 0 1 0. Now how we are converting to the 2's complement form? Before that, this one is the 1 0 1, and then after that we are adding 1. So when we are adding 1, that time what happened? We are getting here 0 1 1 and 1, and so this one and this one, this is our same. Okay, so here I am writing 2's complement form. Are you getting? Any doubt this one?
No, sir.
No, sir.
Okay.
No, sir.
Now what happened? Binary addition overflow during competition. Now what is overflow actually? So what happened? Overflow, how we can detect the overflow? That means we are not performing because within the 4 bit, or here what happened? All the things are completed when we are considering n equal to 4. That means how many bits are we are considering? 4 bit. But some particular operation we are not covering with the 4 bit. More bits are required. So that is called a overflow. Okay. Now what happened? This one is 6 minus 2, it is okay. 4 bits are required. But what happened? If some particular other numbers, 4 bit is not sufficient. Okay, if you are trying to do with the 4 bit, that time what happened? The overflow situation is occurring. Okay. So next, how we can overflow? See, when the sign of two numbers are different, adding them can never result in overflow. That is the very specific condition. And when can overflow occur? When sign of two numbers are same. When the signing of two numbers are same, or otherwise sign of the sum is different from the sign of the either of the numbers. Okay, and also some particular other, but this is also sufficient. This one also some particular other method also exists. That means what? Carry in and carry out. The most significant addition. We are discussing only the most significant addition. That time what happened? That are defined. Then what happened? We can say that is the overflow is occurred. See here how we can overflow is occurred. This particular example, see 6 years 0110. Okay, and 5 is 0101. Okay. So what we are getting? We are getting 1 0 1 1. So that means what? 0 1 1 1 1 1 1 1 0 and 1 0 1. So what happened? Here we are getting the what value we are getting? Well, we are getting 0 1 2 3 8 plus 2. We are getting the 11. And here we are getting, in this particular example, here we are getting minus 8. But remember, when we are doing the addition and subtraction, anyhow, one's complement and two's complement from, because this one obviously what happened? We are some particular addition is there and some particular subtraction is there. Okay, when we are subtraction, that time what happened? Obviously we are using one's complement or we are using two's complement, whatever. Okay, using the one's complement also it is possible, using the two's complement also possible. And this one is the normal binary operation. Okay, now see here, when we are using the ones and twos complement, always remember, see here, plus 0. What is the range? Plus 0 to plus 7. And 1 is called, if you are using the ones complement, that time what happened? That time what happened? We are using minus 7 to minus 8. Sorry, minus 1. Sorry, 0. If you are using the ones complement form. But when we are using the two's complement form, that time what happened? This one is the minus 1 and this one is the goes to minus 8. See here, when this particular first example, our value is 11. But here our range is plus 0 to plus 7. So this one is the overflow. Because 11 is not range with the plus 0 to plus 7. And also if you are using the minus, that time what happened? If you are using the two's complement form, that time what happened? Minus 1 to minus 8. Sorry, minus 1 to minus 1 to minus 8. Okay. So if we are using the ones complement from that time, what happened? Minus 1 to minus 7. So minus 8 is, if you are using ones complement, that time it is not the range with this one. So 0, no, it is not a minus 1, 0, 1, 2, 4, 0, 1, 2, 4, 5, 6, minus 6. It is 0, 1, 1, 0, it is what? It is the
minus 6.
minus. So that means what? It is the minus 6. No, it is not a minus 6. Something I am missing. Oh, no. Minus 6 and so this one is not a 8 and this one is not a minus 6. This one is the minus 10. Okay. So minus 10, if you are using any ones complement from and two's complement from, what happened? So it is minus 10 is not in the range. 11 also it is not in the range and minus 10 also not in the range. So how we can detect how we can know that overflow is coming or not? See, we can check with this particular two condition. One is called a sign of two numbers are same. See here, this is the sign numbers are same. Okay, here also we can say that this particular sign numbers are same, 1 1. And another one is that sign of the sum defined from the sign of the either of two numbers. Sign of the sum defined. So what happened? This one is 0 and this one is 1. Sum is coming in the MSB is 0, but other two numbers are 1 1. So it is overflow is occurred. But remember, in this particular case, the never overflow is, suppose what happens 0 1 0 0. So sign bit is 0 0. But here the next bit, if you are using the opposite sign bit, that means 1 0 1 1. That time what happened? Never overflow is occurred. That means here overflow is not exist. Okay, but when these particular two conditions are satisfied, this one and this one, that time what happened? Overflow is occurred. And another also we can check the overflow is condition is required or not. Carry in and carry out. See here, this one is carry in 0 plus 1 1 and 1 plus 1 is what? 1 0. 1 plus 1 is 1 and 0. So that time what happened? This particular one and earlier carry in is 0, something different. So that way also we can check the overflow is occurred or not. Okay.
So I have a question.
Yes, please.
Yeah, so in the first one where you said when the sign of the numbers are different, adding them can never result in overflow. Then, in case we add 0100 with 1100, then
Yes, just a minute. 0, what you are saying? 0 1
100
0 1 0. No, 1
0 0
0 1
0100 दो बार sir.
Just a minute. 0 0. Yes.
Plus
after that,
1100 1100 plus
1 1
no
0,
sir, plus 1100, not with this.
Acha. Plus 1 1
0 0.
0 0. So what happened? The overflow is never occurred because what happened? This one is 0. Okay. Because which one is the MSB bit? Here in this particular sequence, MSB is 0, and this one is the MSB is 1. Okay. So the sign of the two numbers are different. So this one is 0, different, and this one is 1. So adding them can never result is occur. Okay.
Sir, but
So yes.
yes sir, but if we add them, we get another number to the MSB. I think
Yes.
1 1 1 0 0
1 1 1 1 1 1 0
1 0 0. Yes sir, we'll get 5 bit because there will be one carry left.
No. Your concept is not. So this one is overflow. That means what? This I'm this particular point. I am talking about this particular overflow condition only the addition and subtraction. Okay.
Yes sir.
So what happened when this one is the 1? That time what happened? This one is the 1 means what? We are if you are the extra carry bit is generated. That time what happened? We are going to the based on the 1's complement from or 2's complement from. Are getting my point?
Once.
So
Yes sir. Yes sir. Oh okay sir. Okay sir.
are getting my point? So we cannot
Yes, sir,
use this one. You
Yes,
cannot
sir,
you cannot use one because it is the within that particular range also.
Range sir. Yes sir.
Yeah.
Yes I remember sir. Thank you sir.
So anyone can doubt this one. It is very simple, but remember. So we are designing the bit. Actually, see here n equal to 4, or it is not like that. Whatever I am discussing till now, it is n equal to 4. You can apply n equal to 5, n equal to 6, n equal to 7. Okay, or 8 bit, 12 bit, 16 bit, whatever. Okay, but you can follow the concept. That means how we can the addition is subtraction is performing 1's complement or 2's complement with the help of 1's complement and 2's complement. Okay, then what is the procedure? You can know about the details. Okay, that time what happened? It is very easy. Okay, any doubt this one? बाकी लोग क्या कर रहे हैं? सो रहे हैं? Any doubt this one?
No doubt, sir.
मैं तो 2-3 आदमी का ही आवाज सुन रहा हूँ. बाकी लोग का तो आवाज तो सुनाई नहीं दे रहा है. सभी.
सर
हाँ बोलो.
सर वो राजेश्वरी ने जो एग्जांपल दिया था ना 0 1 0 0 और 1 1 0 0
हाँ
उसको अगर सेम हम अगर पुराने मेथड से जो 2's complement और 1's complement में किसी एक में भी बैठाए ना तो सर आंसर तो सेम वो 0 आएगा ना उसका क्योंकि 0 1 0 0 तो 4 रिप्रेजेंट करेगा ना और 1 1 0 0 -4 और वो तो रेंज 0 होगा ना.
रेंज के 0 होगा.
हाँ तो वो पुराने मेथड बैठाने से सेम होगा ना. क्या बोलते हैं वो 2's complement बैठाने से.
हाँ सेम होगा. ठीक है. If you are using the 2's complement and 1's complement, the result is different. ऐसा नहीं है कि result तो 1's complement का भी same आएगा, 2's complement का भी same, पर वो representation अलग-अलग होगा. लेकिन result वही 2's complement जैसे just this one. So if you are considering C 1 1 0, now what happened? 1 1 0 means what? This particular one bit we are considering as a minus symbol. Suppose sign bit. So here I am writing -2. And someone is asking the remaining bit is 1 1 0. अरे इसका रिजल्ट तो 2 आया लेकिन 1 1 0 का तो रिप्रेजेंट 2 नहीं है. ये तो अलग है. क्या है? 0. If when we are converting this particular 1 1 0 to the decimal, that time what happened? This one is 6. Yes or no?
Yes sir.
1 1 0 is 6 na. So why it is coming -2? Why it is not a -6? Because what happened? हम लोगों ने ऑलरेडी कंप्यूटर को ये स्टोर करके रखा है कि when this one is the 1 1 0, when it is 1 1 0, this particular one is the some particular 0 0 1 0. It is representing this particular 1 1 0 when we are using the 2's complement. ये चीज भी आपको एक साथ ध्यान रखना है. But देखिए same thing if you are applying in the 1's complement form, that is maybe this particular 111 is not coming, but result is coming in the correct form if you are going through this particular procedure. So what happen, your maybe some particular time your concept is not clear, that means your concept is correct, but you're confusing, you are very much confusing. Then only one option you can, now what happen, whatever the problem is coming to you, that means you just discuss with your classmate and try some particular another example and try it, then you can automatically solve. Otherwise what happen, you can ask me. So that time what happen, next class when the class will be started, I am discussing this one, and your concept is clear, then it is okay, no problem. Okay.
Yes, sir.
Yes, sir.
Can you tell me what is the time right now? Time.
10:56, sir. 10:57.
10:57.
10:57, sir.
Okay, 10:57. Just a minute. Okay, 10:57. Okay. So next class, that means tomorrow, we are discussing some about the binary codes. Okay. Suppose BCD, gray code, access tree, this type of things we are discussing, and how these are related to this one. Why this type of codes are required? That means apart from this one, why gray code is required? Why BCD code is required? BCD means binary coded decimal, and why access tree code is required. That particular part we will discuss in the next class. Okay. Okay.
Okay, sir. Okay, sir.
Just a minute. Now I am requesting all of you one by one, you can leave the page.
Thank you, sir.
One by one.
Thank you, sir.
Thank you.
sir.
Just
Thank you,
leave
sir.
the meeting. Okay. Just leave the meeting.
Okay, sir. Okay, sir.
One by one.